Okay, so in this video, we're going to talk about the domain of functions, specifically special functions such as the rational functions and the radical functions. So let's begin. Suppose you have a rational function r of x equals f of x over g of x. So basically what a rational function is that it is a fraction of two polynomials. Excuse me. The domain of any rational function is all real numbers except where g of x equals g of x cannot equal 0. So basically, it's saying that the denominator can't be 0 because the rule is you can't divide by 0. In our first example, we're going to find the domain of f of x equals x plus 3 over x minus 4. So using the rule of the rational function, we want to see where the denominator is going to be 0. So we're going to set x minus 4 equal to 0. And using algebra, we're going to add 4 to both sides, which would then give us x equals 4. So the domain of this function is going to be all real numbers except x equals 4. And to write that in another way, which I call interval notation, we can write it as negative infinity to 4 u 4 to infinity, where that u is what we call the union. Essentially, when you have more than one interval used for domain, we use union to express multiple domains. So we're going to see that throughout other examples in this video. Now in example 2, it's another rational function, but this time it's f of x equals 2x plus 5 over x squared minus 1. So first things first, we'll set the denominator equal to 0. So x squared minus 1 equals 0. Same thing. We're going to add 1 to both sides, which then gives us x squared is equal to 1. Now, when we take the square root here, we're going to get two solutions, plus and minus. So essentially, we're going to look for what is the plus minus square root of 1. And we know that the square root of 1 is 1. So x is going to be equal to the plus minus 1. So the domain here is all real numbers except x equals 1 or negative 1. And in interval notation, we can express it as negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. And at this point of the video, I'd like to just clarify that when we use the parentheses, we're expressing that these values are not included in the domain. So negative 1 and 1 are not included in the domain, as well as negative infinity and positive infinity, because you'll never ever get those exact values. Now for the square root functions, which is a form of radical function, if you have f of x equals a times the square root of x minus h plus k, the domain of any square root function is x minus h has to be greater than or equal to 0. So the rule for square roots is that the inside of the square root cannot be negative. However, it could either be 0 or a positive number. Hence why we're using greater than or equal to 0 inside the radical. So here we have f of x equals the square root of x plus 5 minus 2. So first things first, I'll do x plus 5 is greater than or equal to 0. Then I'll subtract 5 from both sides, which then gives me x greater than or equal to negative 5. So for the domain, it's all numbers greater than or equal to negative 5. And in interval notation, we're going to use a bracket on negative 5 to infinity. That bracket means that negative 5 is included as a solution, because inside the radical, if we do negative 5 plus 5, we would get 0, and 0 is a valid number inside the radical. For the domain of cube root functions, suppose you have a cube root function of f of x equals a times the cube root of x minus h plus k. The domain of a cube root function is all real numbers. So in my opinion, this is actually one of my favorite functions to deal with, because no matter what happens inside the radical, you can take the cube root of a positive and negative number. So for instance, f of x equals the cube root of x plus 2 minus 4. That's just going to be the domain of all real numbers. And in interval notation, it is negative infinity to infinity. Like I said, it's my favorite one because that gives us the least work to do. Now, example 5 is a special rational function. In fact, it is a fraction over a fraction. So in order to do this type of problem and find its domain, the first thing we need to do is actually simplify this and make it look a little bit nicer. So f of x will then equal 1 over x plus 5. But since we're dividing a fraction and a fraction, the numerator is one fraction divided by another fraction on the denominator. That 1 over x plus 5 would then be, well, the 1 over x plus 5 would be there, but then we would have to change the sign from division to multiplication and flip that bottom denominator to become x minus 2 over x plus 4. Now, if we simplify this, we get x minus 2 all over x plus 5 times x plus 4. Now, the results may look like that there are only two undefined values here. However, we need to look back at the original function, the tower, I would say, right? The 1 over x plus 5 all over x plus 4 over x minus 2, right? So if we look at the top part, we can observe that x cannot equal negative 5 because if we plug negative 5 into that top fraction's denominator, it would be undefined, right? And if we look at the bottom fraction, x cannot equal 2 because if we plug it into the bottom fraction's denominator, 2 would give us an undefined solution. Now, if we look at the simplified version on the bottom, we would then also observe that x cannot equal negative 4 as well. So the domain here is going to be a bit crazy to write, but here we go. The domain's negative infinity to negative 5, union negative 5 to negative 4, union negative 4 to 2, and union 2 to infinity. So in a way, we're expressing the three values that are undefined here. We want to show that, okay, from negative infinity to negative 5, it works, excluding negative 5. And then numbers between negative 5 and negative 4 also work, excluding those two numbers. And likewise, negative 4 to positive 2. And of course, 2 to infinity. But remember, all of these are excluded because we can't include them in the solution. Because if we do that, then we're going to get an undefined solution. Last example, it may look a little tricky to find the domain of these two functions, but it's the square root of x plus 5 plus the square root of x minus 2. So the first thing we have to do here is look at the domain of both radical functions separately. So here I'm going to do x plus 5 is greater than or equal to 0, which gives me x greater than or equal to negative 5. And for the second function, it is x minus 2 greater than or equal to 0, which gives me x greater than or equal to 2. Now, you're probably wondering which domain's which, right? So if you're taking the sum, the difference, or the product of two radical functions, I would say the best bet is to take the domain that is the greater of the two, meaning the number that you got, so negative 5 versus 2, right? So our domain here would be 2 to infinity because negative 5 is less than 2. Or you could also say 2 is greater than negative 5. So we'll do 2 with a bracket since it's included, to infinity excluded. So hopefully this video helped you understand the domain of a special function such as the rational and radical functions. Feel free to leave a comment in the video and hopefully this helps.